In this video, I'll be talking about subsets. So we have a definition here. It says, we say that set A is a subset of set B, and this is how we denote that. A is a subset of B, if every element of set A is also an element of set B. Set A is not a subset of B, which we indicate this way. So it's the same same notation as a subset, except for we have that line through it. So set A is not a subset of B if there is at least one element in A that is not in B. That's important to remember when we get to some of our discussion later on in this video. So for an example, if we have B is the set of students in this class, and A is the set of guys in this class, then A is a subset of B. In other words, every guy in this class is also a student in this class. And so we have a subset here. All right, so there's 3 problems I'd like you to do in number 1. So you might want to try those and then watch the video to make sure you understand how this works. So it says determine whether A is a subset of B. So in 1A we have let A equal the set with 5, 7, and 15 in it, and B equal the set with 3, 5, 7, 9, 11, 13, and 15 in it. So if each element in A is also an element in B, then we can say A is a subset of B. Well, 5, 7, and 15 are in both sets. And so, in fact, A is a subset of B, so I'm just going to write yes. In B, we have A, the set with 4, 8, 12, 16, and 20 in it. And B is the set with the even numbers from 0 to 18, so 0, 2, 4, and so on up to 18. And so is A a subset of B? Well, if we can find one element in A that's not in B, then A is not a subset of B. And in fact, 20 is in A, but it's not in B. And so here the answer is no. All right, so in C it says true or false. For any set A is a subset of A. Well, every element of A is going to be an element of A. And so, in fact, this is true. And so this is one of the facts that we want to remember about subsets, is that every set is a subset of itself. Now, I want to remind you of a definition we looked at previously. 2 sets A and B are equal, denoted A equals B, if they contain the same elements. And then I'm going to give you a new definition. It says we say that A is a proper subset of B, denoted A, subset of B. So it's like a sideways U, this symbol. If A is a subset of B and A doesn't equal B. So in other words, the only difference between a subset and a proper subset is you can't be a proper subset if you're equal. So we just talked about how A is a subset of itself for any set, but it's not a proper subset because it's equal. All right, so for example, if A is the set with Texas, Oklahoma, and Louisiana in it, and B is the 50 states of the U.S., then A is a proper subset of B. Well, that would be true because all 3 of those states are part of the 50 states of the U.S., and also these are certainly not 2 equal sets. And so A is a proper subset of B. All right, so let's move on to the next slide. On number 2, it says determine whether A is a proper subset of B. And in fact, we're either going to write proper subset or subset, proper subset, or both in the blank to form a true statement. So in A, we have A is equal to the set of all elements X, such that X is a person and X lives in San Francisco. So these are just people that live in San Francisco. B is the set of elements X such that X is a person and X lives in California. In other words, B is just people that live in California. So is A a subset of B? Well, yeah, because every person that lives in San Francisco lives in California since San Francisco is in California. Are these equal sets? Well, of course not. There's a lot more people that live in California that are not in San Francisco. And so we can say that A is a subset, and we can also say that A is a proper subset of B. All right, on letter B, we have A, the set with 2, 4, 6, and 8 in it, and B is the set with 2, 8, 4, 6, and 2 in it. Now, if you look at these two sets, in fact, they have the same elements, 2, 4, 6, and 8. It doesn't matter the order that they're written. It doesn't matter in B that we have the number 2 written twice. These sets have the same elements in them, and so they're essentially the same set. Well, they are the same set. And so A is a proper subset of B, but we can't say I said that wrong. A is a subset of B, but we can't say it's a proper subset because these are equal sets. All right, on number 3, it says true or false. For any set A is a proper subset of A. Well, we just said that the two sets can't be equal to be proper subset. So this would be false. So we can say that A is a subset of A, but we cannot say that A is a proper subset of A because they're equal. All right, so our next definition, it says here, the empty set or null set denoted braces with space in between, so nothing inside, or it's like a 0 with a slash through it. This is what we call the empty set or null set, and it's the set containing no elements. Number 4, determine which or whether each statement is true or false. All right, so I'd encourage you to try these, think logically through things, and then watch the video and see how you did. All right, so for any set A, the empty set is a subset of A. Well, we could say that the empty set is not a subset if we find something in the empty set that's not in A. Well, since there's nothing in the empty set, we don't have anything in the empty set that's not in A. And so this actually does meet the definition of being a subset. And so we would say true here. So in other words, there's no element in the empty set that's not in A, and so we can say that the empty set is a subset of A. In letter B, we have the empty set is a subset of the empty set. Well, again, you could use the same logic as what we just did in the last one here. There's nothing, well, here's the bottom line. We know that every set is a subset of itself, so that's also true for the empty set. But again, the other way to think of it is there's nothing in the empty set that we will find in the empty set. So this one is also considered to be true. Now, what about C though? The empty set is a proper subset of the empty set. Well, that's not true because we know that with the proper subset, the two sets cannot be equal. So this is false. All right, let's look at number 5. It says if A is equal to the set with A, B, and C in it, find the number of subsets of A. All right, so first of all, let's be a little systematic here. Let's put in the empty set. And then how about the sets that have just one of these letters in it? So the set with A in it would be a subset of A, the set with little a. And we could also do that with B and C. So these are the subsets that just have one of the letters in it. By the way, you notice the set is called set A, and we use capital letters it's generally how we how we name sets. But inside, our letters are lowercase, and so little a is different than capitalized A here. All right, so we've got the sets with one letter in them. How about the sets with two letters in them? So how about A and B, B and C, and A and C. And then finally, we know that A is a subset of itself, and so we'll include the set with A, B, and C in it. So if you count here, you have 1, 2, 3, 4, 5, 6, 7, 8. And so we have 8 subsets here. And actually, we were just asked to list them, but there's actually a formula that we can use to indicate the number of subsets of A. So let's move on to the next slide and we'll discuss that. So the number of subsets of a set with n elements is, and it's 2 to the n power. The number of proper subsets of a set with n elements is, well, the only one that won't be in the number of proper subsets the only set that we would eliminate from the number of subsets would be the one that's equal. And so this is just going to be 2n minus 1. So it'll be one less. You're basically going to exclude the set itself. Okay, so on number 6, it says at the local pizza shop, you can order pizza with pepperoni, sausage, Canadian bacon, olives, or anchovies. How many different types of pizza can be made? Well, we could have any of these toppings or none of them at all, or any combination. And so really this is really the number of sets where we have the toppings. So this is our set, all these toppings, and we could have anything from none of them to all of them. So really this is the number of subsets of the set of all the toppings. And so there are 5 different toppings, so n here is 5. And so 2 to the n power will be 2 to the 5th, and you can see that that's going to be 32. So there are 32 different types of pizza that can be made. All right, that's the end of this video.